Greetings, fellow grade 11s. It's Mr. Hlajayo again. Look, we are back with another video, and what we are looking at today, we are looking at our probability. All right. So we are going to be looking at our probability. Right. So this is basically the topic that we are going to be examining today. Right. Now let's see in terms of what it got for us. Now, firstly, it is important to understand that probability can be understood as the likelihood of an event to take place, right? So it is a likelihood of an event to take place, right? Of an event to take place, right? So this is going to be your probability. And, there are various things that we can use to, understand our probability, right? So, generally what we can understood firstly as probability, it can be, the likelihood or chances of an event to happen, right? And now, which means now when we are having, let's say, an experiment, now it is, for example, it can involve, examples whereby you are tossing your coin, right? Whereby you are tossing your coin, and whenever you are tossing your coin, you want to get a certain number of outcome, right? Isn't it that your coin consists of two outcomes, which is your head and also your tail, right? So which means whenever you're tossing a coin, you're going to have the totality of two outcomes. Now, however, when you are tossing a coin, getting either your head or your tail. For example, if you want to get your head, isn't it that from this particular thing, you are only having one head, right? You are only having one head, which means now the likelihood or the chances of you getting your head is going to be what? It is going to be 1 out of 2 chances. So, which means if we can say now, what is the probability that you are getting a head, the probability of head, then this is going to be same as 1 out of 2 chances, as you are having 2 chances and you only have 1 chance of getting a head out of the 2 chances, right? Similarly, if we can ask of the probability of, let's say, the tail, for you to get a tail, it is going to be what? It is going to be similarly 1 over 2. How to get. So this is going to be, your general understanding of this. Now, for example, let me just give you, let's say you are having your coin, or rather, let's say you are having your dice, right? Let's say you are having your dice. Isn't it that your dice consist of outcomes, which is number 1, 2, 3, 4, 5, and 6, right? Within your die, you are having all these 6 numbers, right? So therefore, you have likelihood. Let's say if now we say, what is the probability of you when you are rolling your die to get, let's say you want to get your 2. So the probability of 2, it is going to be given by what? Look, how many 2s do you have within this? You only have this one number as a 2, right? So which means you have 1 chance of getting a 2 out of how many chances? Out of 6 chances. Isn't it so? So now, similarly, if let's say now we are going to say, now what is then going to be the probability of you getting your even number? Let's say you are having an even number. So how many even numbers are you going to have here? You're having 2, you're having 4, you're having 6. So you're having 3 of them. This is 1, this is 2, this is 3. So you're having 3 even numbers. So this is going to be therefore 3 out of 6 numbers, right? And this can be furtherly simplified as 1 out of 2. Isn't it so? Right? And now let's say also we say, now what is the probability that you are having a number that is relatively odd, right? So the number that is relatively odd, therefore it can be understood as what? An odd number is what? It's going to be your 1. Let's get another nice color there. So your number that is going to be odd, it is going to be what? Firstly, it's going to be your 1, your 3, and your 5, which means, can you see that you are still having 3 numbers out of 6? Isn't it so? So this is also still understood as 1 over 2. And now if let's say we are saying now, what is the probability of you getting now, let's say, numbers divisible, numbers that are divisible by 3. right? So numbers that are divisible by 3, basically number that you can divide 3 with, right? And numbers that you can divide 3 with here, can you see that is going to be 3 and also the 6, right? So which means the probability of divisible by 3, it is going to be 2 numbers out of 6 numbers. Are we together? Now, this is just the general understanding of us understanding these probability of ours. But now, just like any other topic, we are all governed by the rules, and therefore also within probability we have also the rules that govern us in order to understand what probability is, right? So now, to begin with, for example, now you can represent, if let's say you have this scale, you can be in a position to represent your probability here, right? For example, now, if let's say you are having your scale starting from 0 to 1 to understand our probability, right? Now, if let's say now the probability is 0, right? Probability is 0, which means it is almost impossible. It is almost impossible for that particular event to occur, right? Or which means it will not occur, right? It will not occur or it will not happen. Altogether, for example, when you are having your coin, remember you're having your head and your tail. There is no possibility that you can get head and tail at the same time, right? Because you can either get your head and also your tail, but you cannot get head and tail in the same time, right? If you're having one coin, which means the chances there are almost impossible. And here you are going to have these now are these which we regard them as likely chances, or others they say it's fair chances, right? Which means this is half chance, right? This is when you're having the 50% chances of something happening, right? You're having the 50% of something happening, and now you're also having the one which is the possible, right? Which is the possible, which means we can also say it is a certain, or yes, so this is going to be now the certain chances of something to occur, which means there is 100% of chances for this event to occur. But now isn't it so that you can still also have quarterly chances whereby you're having 1/4 altogether, which means these are going to be the least likely, right? Least likely chances for an event to occur. And then whereas now here, let's say you are having your 3/4. Remember this, your 1/4, it is your 25 percent chances. And now this one is going to be what now? Your 75 chances, right? Or 75%. So which means this is going to be most likely, right? We are not saying it will occur, but it is most likely that it will occur altogether. So you can be in a position now to understand all these particular rules and what govern us, right? So now that we at least understand these basic fundamentals, I want us now to start and look at now the formal way of understanding this probability. Now let's start here. So we are saying now, firstly, you are having this thing called a sample space. A sample space, right? And basically what a sample space is, it's where you are having all the possible outcomes, right? All possible outcomes. So which means whenever you are having all possible outcomes, we represent them within our within our sample space, right? So we are going to say our sample space. For example, the sample space for you getting either your head or your tail, it was 2. And the sample space of you when you are rolling a dice, it was going to be 6 because you had 6 chances of getting any of those things, right? Or rather on any of those numbers. So that's basically your sample space, isn't it so? And now and it can be represented by your what? Your n, which is also the s altogether. So, and what is it that you can also understand now? We are saying now probability can be represented in this format. Now we are saying now your probability of a single event, right? Now, if you want to represent the probability of an event, the probability of, your event can be understood as what? As the number of favorable outcomes. So this is going to be the number of favorable outcomes versus what? Outcomes, favorable outcomes over what? This is number of favorable outcomes over the total possible outcomes, which means whenever we are representing our probability, right? Isn't it that we are saying we are having 1, 2, 3, 4, 5, 6 numbers, right? So the possibility, let's say when we were looking for the probability of numbers that were divisible by 6, which was 3 and 6, right? Which means this was going to fall under what? Under this, which, because this was the 2, which is the number of favorable outcomes. Hey. And now after that, the denominator then was going to be now the total possible outcomes, which was what? Which is the 6 now. Are we together? So basically that's how our probability is represented. Right now, I want us to continue now understanding some of the nitty-gritties along these things. Right now, for example, what you also need to know is that now you can have chances where you are having, let's say, 2 events occurring at the same time, right? So we are having this, which we call an intersection. We have what we call an intersection. Basically, an intersection can be represented by this symbol. So your intersection can be represented by this, your N symbol that is looking downward, which is going to be what? The intersection means what? Intersection means and, right? Which means intersection means the probability of A and your B, right? Don't worry about this. We are going to, still go and understand this immensely. Now, but what you need to know is that intersection is when you include these events now, right? It's when you have your event A and your event B occurring at the same time, right? So that is basically going to be your intersection, while your union, right? And before we move to intersection, and intersection is also associated with multiplication, right? Whereas your union now, it is what? It is your U again looking upward, right? And now this is going to be understood as the what? When you are having a probability of A or B occurring as in it so at the same time. And this can be understood as our what? As our plus, right? Or rather as our addition of these particular events. And now let's just try and make up some space so that we can understand all these other things now, right? So amongst the other things, let's see, I want us to go through the rules, and then so that we can now after that apply all the rules into our calculation. So now let's see. So we are saying we are having all these other types of events. Let's start with this. Now, firstly, we are saying now we have the events. Now we are having these events, which we saying these are complementary events. Complementary events, right? Complementary events. No, in simple essence, complementary events, it's when basically two events complement each other. You usually use this name complement in our everyday life. It's basically when two items can coexist as one item, right? Or rather, which means in this context, it's when you have the probability of what? The probability of A with plus the probability of not A and A not. This particular thing here, this represent not, right? So the probability of A not giving us 1. So these can be represented, or this can be understood as what? As our complementary events, right? And after complementary events, we are having now what we regard as now firstly our mutually inclusive events. Mutually inclusive events are inclusive events. Now, how can we understand our mutually inclusive events? Let me start by giving you the formula, then we can understand the mutually inclusive events. Now, let's say for example, now you are having this. The formula for mutually inclusive events, it's when you have probability of A or B, which is equals to the probability of what? The probability of A plus the probability of B, subtract the probability of A and B. All right. Now, let me just give you the narration of this. Let's say I give you this. Let's say you are given a series of numbers, the sample space, which represent number 1, 2, 3, 4, 5, 6, 7, and 8. Let's say you also have 9, right? This is me trying to explain mutually inclusive. So please be patient with me here. Now, we are saying firstly, if you are having the probability of A, let's say I give you that the probability of A, it is going to be given by even numbers, right? Which means it's going to be given by 2, 4, 6, 8, right? And now the probability of B, it is given by what? It is given by your number what? It is given by all the numbers up until 6, right? It is given by number 1, 2, 3, 4, 5, 6 altogether, right? So we are saying this is event A, this is event B. And now we are saying if now you want to understand mutually inclusive, if let's say you are represent this thing in our Venn diagram, right? So the first thing that we are going to do is the Venn diagram, you draw a square-like shape, then you represent your 2 cycles, right? You are going to represent your 2 cycles. But now, mutually inclusive means that now what occurs in event in probability of A is also the same as in probability of B, which means a value that appears in your probability of A is also going to be the same value that will appear in your probability of B. Now, if you can check what is common between these two numbers, or rather between these two probability, look, if you can check 2 here and check 2 here, it is they are present. Look, you can check 4 and 4 is here. You check 6 and you check 6. Can you see that all these 3 numbers are what are appearing in both of these particular events? So therefore, if you can then let's say you are drawing your Venn diagram, you are going to now draw your 2 cycles, and your 2 cycles are going to intersect, right? And this inner part here, this is where you're going to represent your 2, your 4, and your 6, because look, this is your probability of A and this is your probability of B, and your 2, 4, and 6 appear in both of these particular events. Are we together? And these values that appear here, or if you are having anything here, right here as part of your intersection, we are saying these events are mutually inclusive, right? Which means they are mutually inclusive because your probability of A and what? The probability of A and B, you are having a what? You are having a value for the probability of A and B. How to get? So whenever they want you to basically look at your probability of A and B, or to determine whether you are having something that is mutually inclusive, you are going to look at these particular events and look at whether do you have your intersection, right? And if you have your intersection, and then yes, you can conclude on mutually inclusive. And what else you can do, which means now what you need to know is that the fundamental principle of mutually inclusive is that now, can you see that the probability of A and B in mutual inclusive, it cannot be equal to 0, which means you cannot have 0 there as your inclusion, right? You cannot have your 0 here, you cannot have your 0 here as your inclusion, or rather where your 2 cycles meet. Are we together? So if you are having a value where your 2 cycles meet here, then which means your events are mutually inclusive altogether, which means they both events occur at the same time, right? So I tried to understand to make you understand that, but we are going to continue to look at it as we continue here. Now, so that is going to be mutually inclusive, right? Now let's try and then understand now what is therefore going to be mutually exclusive, right? So we've understood mutually inclusive. Now let's go to mutually exclusive. So we are saying now for mutually exclusive, I think already you are in a position to understand what is then going to be your mutually exclusive, right? Now for mutually exclusive, what will basically happen is that now it's when your probability, you have your probability of A and B, or rather not A and B, but rather probability of A or B, giving you what? Probability of A plus your probability of what? Of B altogether. So this is the formula for mutually exclusive. Let me make you realize this. Can you see that in this case, let me write this with the different color. Can you see that here there is no probability of A and B, which means from your mutually inclusive, your probability of A and B here is what? Is excluded, right? Can you see the word exclusion? Which means the probability of A and B doesn't exist or does not exist, which means basically now, if you are seeking to prove the mutually inclusive, you must prove that the probability of your A and B must give you what? Must give you 0, because you do not have an intersection, which means if you can come here, now let's say you are representing your Venn diagram, right? So which means your Venn diagram are going to be independent for each other. There's nothing that combines them, right? There's nothing that combines them, isn't it so? And then that is going to be basically your mutually exclusive. So that's some of the things that I want us to understand when it comes that, which means you can say these ones are not joined. This is not joined altogether. This for mutually exclusive, it is not joined, which means there is nothing common in between there, right? So that's basically going to be your mutually exclusive altogether. And now let's try and get some questions and see in terms of how can we then apply all these concepts that we are talking about. Let me just make up some space here. Yeah. What do we know about cards? Look, I know this is probably an unfamiliar concept with you, but let me take you through. Isn't it that from your card, you are having cards ranging from number 1, which is an ace, up until your number 10. And then after that, you are having your J, K, and what? And queen, right? J, K, Q, right? And your ace representing 1, which means you're having your card basically ranging from 1 up until 10. And the second thing that you know is that each card consists of what? It consists firstly of your heart, it consists of your diamond, right? Consists of your diamond, it consists of your, your spade. It consists of your spade, right? And lastly, it consists of, I usually regard this as your grape, right? Yes, this is going to be your grape, right? So each and every card consists of all these all these three shapes or the symbol, which means now your ace, which means 4 of your ace, which means almost all the numbers starting from ace is going to have 1, 2, 3, 4 of each of these particular shapes altogether. Now that is going to be basically your cards. And now if they want you to now determine what they want you to determine the probability of what? Of getting a 10 or a heart when you draw cards from what? From a pack of playing cards. Now let's start here. So in totality, the number of cards that you're having is you are having 52 cards. You are having 52 cards. The 40, the 40 is the numbers, right? It's the numbers, and the JK queen what represents the what? The JK queen represents the what? This is going to be also them. And how many are they? They are 12 in totality, because you are having 4J, you are having 4K, you are having 4 queen, right? So which means now let's start here. And we are going to say firstly, what is going to be the probability of 10? The probability of 10. The probability of getting a 10. The probability of getting a 10, it's going to be 4 out of how many chances? Out of 52 chances, because you'll have a 4 of your what? You have your 4 of your heart. You have your 10 of your heart, your 10 of your diamond, your 10 of your your spade and your 10 of your grape, right? Which means you're going to have 4 of those. Now, if they also now want you to determine what is going to be the probability of your heart, right? This is the probability of heart. Now, how many cards are going to have the heart? Look, from numbers, almost from ace up until number 10, all of them, they do have a heart, which means you are having 10 from the number side, and from your JK queen, all of them, the 3 of them, also they do have what? They do have your heart, which means in totality, you are having 13 out of what? Out of 52. Out of 52 who are having your heart altogether. And now, if I can come back here and say now, what will then be the probability of both of these? The probability of 10 and heart. Is there possibility that you get a 10 and also a heart, right? Which means that is going to the probability of what? If let's say now I want to find out what is the probability of 10 and a heart, right? Now, look, remember how many 10s are you having? Remember, you're only having 4 10s. And for you to get a heart from the 10s, it's going to be what? It's going to be only 1 chance, right? So which means you're only going to have 1 chance out of what? Out of 52 chances for you to have a 10 and also a heart, right? So which means now when you then want to calculate here the probability of 10 or your heart, basically here you are going to come back and use the mutually inclusive formula. You say now, look, the probability of what? Of 10 or your heart, right? It is going to be represented by what? The probability of your 10. As in, so the probability of your 10 plus your probability of your heart, right? Plus the probability of your heart. Yes, this is your heart. And subtract the probability of your 10 and your heart, getting your heart, right? So what is it that you're going to get? What is the probability of 10? It was 4 over 52 plus the probability of your heart. It is 13. It is 13 over 52. Subtract 1 over 52, which means now if you are seeking to calculate what will be the probability of 10 in the heart, it is going to be 4 over what? It's going to be 4 over 52 plus what? Plus your 13 divide by 52, and then this is going to be also subtract 1 over your 52. How to get? And the answer that you're going to get there, which means your probability of your 10 or your heart is going to be given by what? 4 over 13, right? This is going to be your answer. Look, I know this is probably, a little bit, complex for you because you're still trying to conceptualize this, but let's get more and more example to try and understand this. They say now, during an experiment, it was found that the probability of A is 0.25, the probability of B is 0.5, and the probability of A or B, it is what? It is 0.625. Now they want you to find out what is going to be the probability of A and B, right? And, for me, I would say basically here, they want you to prove whether is this going to be mutually inclusive or not, right? And is it going to be mutually inclusive or not, right? Because look, if you can find the value for probability of A and B, then you can conclude that these are mutually inclusive, right? So now let's start here. So for you to make use of this, you are going to make use of the mutually inclusive formula, right? So which means bigger, because you are having the probability of A or B, right? Which is going to be equal to what? The probability of A plus the probability of B, which is going to be subtract the probability of A and B, right? It's going to be probability of A and B. And what you need to take note of is that now, firstly, the probability of A or B is going to be given by what? The probability of A or B, you already have these as 0. What? As 0.625. So this is going to be 0.625 is equals to what is the probability of our A? The probability of our A is given by 0.25 plus the probability of our B. It is going to be given by what? The probability of our B, it is going to be given by what? 0.5, and you subtract the probability of what? of A and B that we are looking for, right? And what is it that you are going to do now from here? Then you'll come back and say, now look, you can simply just take this side, right? And take this particular one, this other side, right? So let's try and do that. So you're going to say, look, now your probability of A and your B, probability of A and your B is going to be given by what? It is going to be the 0.25 plus the 0.5 subtract the 0.625. Now, what is therefore going to be your answer? This is going to be 0.25 plus 0.5. Yes, 0.5 subtract the 0.625. And the answer that you are going to get basically there, let's see. Let's fix that. The answer that we are going to get from here, it is going to be what? It is going to be 0.105, right? So basically, this is going to be 0.125. Altogether, this is going to be the answer that you are going to get for your probability of A and B, which means your probability of A and B is basically given by 0.125. Now, let's look at the second one. Now, let's look at this one. Now, for this one, what is it that you are given? Here for this one, in number 3, they say given that the probability of A or B, your probability of A or B is given by 0.6, the probability of B is given by 0.4, the probability of A and B is given by 0.3. Now, they want you to first determine what is the probability of A. Now, one thing that you need to take note, as soon as you see this, right? As soon as you see this, you need to know that this is mutually inclusive, right? Remember, because I explained in the beginning of the video that mutually inclusive means that there is an intersection for the probability of A and B. So therefore, you'll come back here and say, look, now my probability, my mutually inclusive formula is represented by what? This is probability of A. Look at me writing wrong things there. Look, this is going to be what? The mutually inclusive is going to be the probability of A or B is going to be equals to the probability of what? Of A plus the probability of B subtracts the probability of what? Of A and B. That's the mutually inclusive formula. Then you come back, you just plug in the things that you are given. You just plug and play. Look, are you given the probability of O? Yes, this is going to be 0.6 is equals to what is the probability of A? The probability of A, it is the one that we are looking for, plus the probability of B, which is 0.4. Subtract what is the probability of now your this other one, it's 0.3, right? The probability of A and B, which is this one. And now what is it that you're going to do? From this one, you're going to simply say, now look, if you can just subtract this, already you can see that this is going to be 0.6 is equals to the probability of A plus what? Then when you see 0.4 subtract 0.3, this is going to be plus 0.1. Isn't it so? When you subtract those, and now you're going to take this particular value and transpose it this side. And when you do so, which means your probability of A, therefore, is going to be given by what? The probability of A is going to be given by 0.6 subtract 0.1. And when you do so, then what is going to be your answer then, which means the probability of A is going to be given by 0.5, right? So which means your answer here is going to be 0.5. Now they say if event A and B are mutually exclusive, give a reason for your answer. Determine now. But they want us there to determine that if the events A and B are mutually exclusive, give a reason for your answer. Are these going to be mutually exclusive? Are these going to be mutually exclusive? No, because look, we've already proven that these are mutually inclusive. Why are we saying so? Because you have a value for the probability of A and B. So, which means now you are going to say, are these going to be mutually exclusive? No. What is going to be the reason? That because the probability of your A and your B is not equals to 0. Remember, which means now if let's say you are going to draw your Venn diagram here, right? What was going to happen basically, this particular part, it was not Remember, this one is having something in between. And for mutually exclusive, it must not have anything in between, right? So therefore, and here you are having your A and B, right? Which means you have something in between. So therefore, this is not going to be mutually exclusive. How to get now? Hopefully, this will make sense to you.